Hey everyone, welcome to another video. Now, we've talked about surface area a couple of times, both in the last video and the one from the topic of measurement in the Year 8 playlist, the Year 8 series. Now, one particular shape that we've learnt about, but we haven't really looked into just yet in terms of surface area, is a cylinder. So in this video, we are going to be looking at how we can think about breaking up a cylinder into the different shapes and surfaces that we can measure. Now, I have a cylinder down here, and all cylinders have a radius, let's call that R, and they have a height, let's call that H. The height from top to bottom. Now, if I wanted to count the different parts of my cylinder that I have, well, what we looked at before with cylinders is they have a cross section of a circle. So that means there is a circle that goes all the way through this shape. Now, both top and bottom, we have these identical circles. So we can break those up here. So we can say that a cylinder is made up of two circles with the radius R. Now, cylinders we see a lot in everyday life. If any of you eat Pringles, imagine this dissection, breaking this up as taking the lid off your Pringles box and then taking off the little tin bit down the bottom. So I like the Pringles analogy because a lot of people, at least in Australia, have tried these. They know what I'm talking about. But if we take off these two circular bits, what's going to happen with this remaining area, this bit wrapping around the whole thing? Well, if we take that circular bit, and let's say we take this curvy bit around the sides, and let's say we cut this, say here. We cut this bit along the edge in half, and then we started to unravel it. Now, you would notice at first, if we started to unravel it, it would look something like this. We would have, for example, this curvy bit, and we would start to break up. So say if this point belonged here at first, connected, and we started to unravel that, we would slowly get a flat rectangular sheet. Try this with a piece of paper. Try taking a rectangular bit of paper, folding the edges over, or bending them around, and you will notice you make a cylinder. So when we deconstruct this middle bit, once we take off my top circle and my bottom circle, we can unravel the rest to make a rectangular sheet. So we get this sheet up here. We only get one of these here. But now that's cool, but it doesn't really help us, right? Because we want to know, well, what are the two dimensions of my sheet? Well, one of them, if we say made this cut and we looked at this particular thing here, that corresponds to my height from top to bottom, either here or here or here. So my dimension over here is going to be my height. And what is this particular side of my rectangle here? How did I get that? Well, that was made up from unraveling. Once we made a cut here, for example, that was made by unraveling this bit here and this bit down here. They correspond to the top and bottom of my rectangle. So you see this here as well, these two. This is just us opening up the circle. And what part of a circle would this entire length be? This one from here to here, and this one from here to here. Well, that's going to be the circle's circumference. So this thing here is actually the circumference of that circular bit, which is, as we remember, 2 pi r. So if we wanted to find the surface area of a, if we wanted to find the surface area of a circle, we would need to consider the surface area of a cylinder. We would have to consider the two circles as well as the rectangular sheet in the middle. So let's try to make a formula here. We're going to derive this. Now, the surface area we get from adding the area of all of the individual surfaces. So we have two circles, which we get from doing 2 times pi r squared, and we're adding that with the area of this rectangle, whose dimensions are 2 pi r for one, and h for the other. So timesing those together, we get 2 pi r h. 2 pi r h. Now that is the surface area of a cylinder. Now that we have derived this formula, let's apply this to a couple of questions. So in our first question, I have drawn a cylinder here. That's a poorly drawn cylinder, my apologies. But I have a radius of 5 meters and a height of 25 meters. And I want to find the surface area. Well, once again, I'm considering what I derived just now, an area of 2 circles as well as the rectangular bit that wraps around. So I'm going to do, putting that into my formula, I'm going to do my surface area equals my 2 lots of pi r squared. Now my radius here is 5. So let me put that in. So 2 pi times 5 squared. And to that I'm adding my 2 times pi times my radius 5 times my height 25. So this first bit corresponds to my 2 circles on the end, and this bit of my formula here corresponds to my bit that wraps around, my rectangular sheet up here. This is my 2 pi r h. So once I plug all of those into my equation, if I wanted to write this in terms of pi, I would have, this would simplify to 50 pi plus 250 pi, and we get 300 pi. Now if I wanted this in exact units, I would leave it like this because pi is an irrational number, so applying the multiplication will immediately give me an irrational answer. So this is it in, and I should write my units, meters squared. So this is it as an exact value. Sometimes questions will ask you for an exact value. All we mean by exact value is that we leave it in terms of any irrational numbers like pi, for example, or we can say that's approximately equal to 942.48 meters squared. This is to 2 decimal places. So we are just applying a pretty stock standard approach to the equation we derived up here. Now let's look at where this changes, because before, when we talked about cylinders a while back, we said that we can get more than one type of cylinder. Remember, we could get these half cylinders, we could get these different types of portions of cylinders. So what I'm going to do now is I'm going to draw a little half cylinder here. There. That's really badly drawn, sorry about that, but that's my half cylinder. Let's move this down a bit. Let's fix this up actually, shall we? Here, and that's gonna look kind of like that. And this is gonna meet about here. So, we have to consider all of the surfaces. Let me put a couple of measurements here, all the ones we need. Now, we want to find the surface area of this half cylinder, and then we want to round it to 2 decimal places. Now notice, I have 2 semicircles. So if I combine those areas, that's just going to be the same as finding the area of just one whole circle. So I can write that down here. My surface area is going to equal my pi r squared, because 2 semicircles make a full circle. So let me break this down here too. So I have 2 lots of my semicircle. I have this face down the bottom here. That's just a purely rectangular face down the bottom. So I have to consider that too. Because think about it, if we chop a cylinder in half, a new surface appears, this flat bit in the middle. So that's going to be, we have 1 lot of my rectangle down the bottom. Let me just put my measurements here as well. So I have 4 centimeters. This is an 8 centimeter by 4 centimeter. And I also have half of my round curvy bit. So this type of thing here, which also ends up being a rectangle. But let's think about when we unravel this, right? Because we are considering here the rectangle that appears ends up being half of my regular rectangle. So instead of, I'm going to say there's also 1 lot of this other rectangle. Now its height is still going to be the same. It's still going to have a height of 8 centimeters because the height's not going to change. But this bit here that we unravel in the same way we had up here, that's going to be, well, my circumference divided by 2 or times half. So it's going to be half times 2 pi r centimeters. So that is how this changes now. We are looking at the circumference of half a circle because it's a semi-cylinder, right? So the 2 edges are semicircles. So we'd expect when we unravel this for the length up here to be a little shorter. Now, let's just bring this down here and sub in all of our values. So my 2 semicircles is going to be my pi. It's the same as just a regular full circle. The area of a full circle, so that's pi times my radius is, well, 4's my diameter. So my radius halfway across is going to be 2. So from here to here, that's 2 centimeters. So I have pi times 2 squared. And then to that, I'm going to add 8 times 4, my rectangle on the bottom here. And then to that, I'm going to add half times 2 pi times my radius of 2 times 8. That's my area over here. So I've multiplied this dimension, my half times 2 pi r, times 8 here. And that's going to be approximately equal to, once you pop it into a calculator, that's going to be 94.83 centimeters squared to 2 decimal places. So for questions like this, we have to be cautious about when our shapes get cut or divvied up in ways like this, because new surfaces appear depending on the shape. So if we cut a cylinder in half, well, assuming it's not hollow, we're going to get this rectangle down here, or this one over here. So we have to consider that when we approach these trickier questions. Don't let this fool you. Just do the same thing we've always been doing. Count up all your surfaces. You can draw them on the side if you'd like I've done here. And then we just apply what we know about surface area. So find all of these separate surfaces, the separate areas of the surfaces, and add them together to get your final answer. But that is how we can think of finding the surface area of cylinders. Thank you so much for watching, guys. I'll see you in the next video.